8:55 வீட்டுக்கு போனால் ஓகே. Hi students, welcome to Future Doctor NEET Academy for the YouTube live session in Crash Course NEET Physics. Topic today chosen is from Chapter 1, Physical World. This is from 11th standard, first chapter. Physical world or physics world, we can say in any way. Science. Science means organized knowledge. Science is human nature to observe things and happenings around in the nature and then to relate them. That is whatever things present in surroundings. That is the science. This knowledge is organized so that it become well connected and logical, then it is known as science. It is a systematic attempt to understand natural phenomenon and use this knowledge to predict, modify and control phenomena. Scientific methods are used to observe things and natural phenomena. It includes several steps, that is observation, controlled experiments, mathematical modeling, prediction and verification or falsification of theory. Verification means proving the theory, particular theory. Falsification means disproving, failure of the theory. That is disproving, falsification. Classification of science. Science broadly classified as physics, chemistry, biology, and biology further classified as botany, zoology. Physics is a study of basic laws of nature and their manifestation in different phenomena. Principal thrust in physics. Thrust in physics means areas in physics. There are two principal thrusts in physics. One is unification, another one reduction. Okay, two things. One is unification, another one reduction. Unification. Efforts are made to explain different phenomena in nature on the basis of one or minimum laws. This is called principle of unification. That is, for example, Newton's laws of motion. It is applicable for, that is, force between the object and the earth. And same Newton's law is applicable for force between the planet and the solar system, sun, and the force between the planet and the satellite. Okay, that is a unification. Example, phenomena of apple falling to ground, moon revolving around the sun. This is only I said. Gravitational force, all are gravitational force only. And weightlessness in the rocket. Why there is a weightlessness in the rocket? Because there is no gravitational force there. In free space, no gravitational force. All these phenomena are explained with the help of single law, that is Newton's law of gravitation. Progress in unification of different forces or domain in nature. That is, Isaac Newton in the year 1687, achievement in unification, unified celestial and terrestrial mechanics. Celestial means bigger objects, heavy objects, that is force between planets, bigger particles. Terrestrial mechanics. Terrestrial means within the earth's surface. That mechanics showed that same laws of motion and the law of gravitation apply to both the domains. Hans Christian Ørsted, Michael Faraday showed that electric and magnetic phenomena are inseparable aspects of a unified domain, that is electromagnetism. There is a link between electric and magnetic phenomena. That is given by Ørsted and Michael Faraday. James Clerk Maxwell, unified electricity, magnetism and optics, showed that light is an electromagnetic wave. Okay, electromagnetic wave, electricity, electromagnetic, magnetism, and EM wave is a light wave. That is optics. And Glasgow and Abdus-Salam and Weinberg showed that the weak nuclear force and electromagnetic force could be viewed as different aspects of a single electroweak force. Rubio and Vandermeer verified experimentally the prediction of the theory of electroweak force. Reductionism. So far is unification, now reductionism. To understand or derive the properties of a bigger or more complex system, the properties of its simpler constituents are taken into account. This approach is called reductionism. It is supposed to be the art of physics. For example, a complex thermodynamical system can be understood by the properties of its constituents like kinetic energy of molecules and atoms. That is, the thermodynamic system can be applied with kinetic theory of gases, and it can be extended for thermodynamics. The scope of physics can be divided into two domains, macroscopic and microscopic. Macroscopic means bulk particle, bigger particles. Microscopic, smaller microorganism like particles. Macroscopic domain includes phenomena at the level of laboratory or terrestrial on the Earth's surface. Astronomical scale. Astronomical means in space, throughout the space. Microscopic domain includes atomic, molecular and nuclear phenomena that may be measured in Armstrong or micrometer or Fermi. Recently, third domain in between these two also used, that is called mesoscopic physics. This deals with group of hundreds of atoms. Scope of physics is very wide and exciting because it deals with the objects of size as well as universe, 10 power 25 meter, and as small as size of the nucleus of the order of 10 power minus 15 meter or minus 14 meter. In terms of Fermi means we can say 10 power minus 15 meter. That is size of the nucleus. Excitement of physics is experienced in many fields like live transmission through television. Computers, this is also live transmission. And computers with high speed and memory. Use of robo. There is a computer with high speed also is a tremendous application. And memory storage. That is, I said no, that is for, we found the answer for DVD. Storage capacity of DVD. Okay. That is high speed and memory storage. For the storage capacity, that is, I said no, that is even one CD. Compact disc, 700 MB only. Few songs only, not even single film. 2.5 hours running movie, that is not sufficient in one CD, 700 MB. That is at least 2 or 3 CD we have to give, we have to copy for one film, 2.5 hours. But in computer, that is, it may be appears as the storage capacity of the hard disk will be in TB, terabyte. GB, 1000 GB or like that is going. Use of robo. Lasers and their application. In chemistry, chemical bonding, that is a chemical bonding based on physics only doing. Atomic number and complex structure can be explained by physics phenomena of electrostatic force taking help of X-ray diffraction. That only I said XRD, X-ray diffraction studies. That is my research. XRD studies. XRD will be two types. That is powder XRD studies, powder X-ray diffraction, single X-ray diffraction. My research is single X-ray diffraction study. So in there we are finding the atomic, that is atom's location, that is a bond length, bond angle, whether it's a triple bond or single bond, that things and all will be studied and can take photograph and doing that one, that is the XRD study. Physics in relation to biological sciences helps in study of biology through its invention. Optical microscope helps to study biosample, already we said. Optical microscope, its magnification will be 1000x. Electron microscope helps to study biological cell. Electron microscope in quantum we have studied. And X-rays have many applications in biological sciences. Radioisotopes are used in cancer, treatment of cancer. Not only in cancer, also it's used in agriculture. As a radio phosphorus, radio iodine, like that. Radio nitrogen, that and all will be used. In astronomy, giant astronomical telescope developed in physics are used for observing planets, stars, supernova explosion, like that. Radio telescope have enabled astronomers to observe distant limits of universe. Physics related to other sciences, laws of physics are used to study different phenomena as in other sciences like biophysics, that is a link between biology and physics, that is separate biophysics, like just like biochemistry, biophysics. Oceanography, study about oceans. Seismology, what is seismology? Seismograph. Seismology is a branch of physics that is about earthquake, study about the earthquake. Okay. There is a large number of forces experienced or applied. These may be macroscopic forces like gravitation, frictional force, contact force, microscopic force like electromagnetic and interatomic forces. But all these forces arise from some basic force called fundamental forces. That is, there are 4 fundamental forces in nature. One is gravitational force, second one electromagnetic force, and third one weak nuclear force, and last one is strong nuclear force. Why I kept last one as strong nuclear force means it is the strongest force. Already we have discussed. Gravitational force is the weakest force and nuclear force is the strongest force. Nuclear force, strong nuclear force is the force between nucleons. That previous class only we have discussed that force between the nucleons must be of the order of Fermi. It should be in 2 or 3 Fermi. Above Fermi means there is no nuclear force and it is a charge independent. Proton, proton or neutron, neutron, whatever, it will be always attractive, like that we have discussed. Gravitational force, it is due to mass of 2 bodies. It is always attractive. There is no repulsive force in gravitation. It operates in all objects of universe. Its range is infinite. That is, we said no, that is for nuclear force, it will be a short range force of the order of 2 to 3 Fermi. But it's not like that, it's a infinite. It is a weak force, weakest among all the 4 forces. Approximately 10 power minus 38 or 10 power minus 40 also will be used times compared to strong nuclear force. Second type, electromagnetic forces. It is due to stationary or moving electric charge, may be attractive or repulsive. It operates on charged particle. Its range is infinite. It is stronger 10 power 36 times than gravitational force, but 10 power minus 2 times of strong nuclear force. Third type, strong nuclear force. Operate between nucleons. What are nucleons? What are nucleons? Protons and neutrons are together called as nucleon. It may be attractive or repulsive. Is it repulsive? No. Attractive only. That is, if it is more than that, no effect, that's all. Weak nuclear force. Operate within nucleons. Elementary particles like electron and neutrino. It appears during radioactive decay. And short range of the order of 10 power minus 15 meter Fermi range. And it is 10 power minus 13 times stronger than strong nuclear force. 10 power minus 13 times less than strong nuclear force. And this is the fundamental forces, 4 fundamental forces of nature, the relative strength, range and operates among. Gravitational force, all objects in the universe. Weak nuclear force, elementary particles, particularly electron and neutrino. Electromagnetic force, charged particle. Strong nuclear force, nucleons and heavier elementary particles. Conservation laws. In any physical phenomenon governed by different forces, several quantities do not change with time. These special quantities are conserved quantities of nature. For motion under conservative force, total mechanical energy of a body is constant. Total energy of a system is conserved and is valid across all domains. All domains means all the branches of science, of nature, from microscopic to macroscopic. Total energy of the universe is believed to be constant. Conservation of mass was considered another conservation law till advent of Einstein. That is after Einstein E equal to mc square, till that mass is constant. But mass can be converted into energy. Energy can be converted into mass. That was proved by Einstein. Then conservation of mass was disproved. Then it was converted to law of conservation of mass plus energy, because mass is converted into energy and energy is converted into mass as per Einstein's equation E equal to mc square. The examples are pair production and pair annihilation. Pair production, best example, electron and positron production. Pair annihilation, that is electron and positron when combines, then it emits some radiation, that is pair annihilation. Momentum is another quantity which is preserved. Similarly, is angular momentum of an isolated system also constant, conserved. Conservation of electric charge is a fundamental law of nature. Later, there was development of law of conservation of baryon number, lepton number and so on. Baryon number, lepton number and all, elementary particle. These are the basic for the proton, neutrons. Proton, neutron, electron. Okay. And laws of nature do not change with change of space and time. This is known as symmetry of space and time. Symmetry means regularity. This and some other symmetries plays a central role in modern physics. Conservation laws are connected to this. And these are the major contribution discovery of the name of the scientist with the country origin. Archimedes, principle of buoyancy, principle of lever, belongs to Greece. Galileo, laws of inertia, Italy. Huygens, wave theory. Isaac Newton, law of gravitation, laws of motion, reflecting telescope. He belongs to UK. Michael Faraday, laws of electromagnetic induction, and Hertz, Rudolf Hertz, generation of electromagnetic wave, Germany. J.C. Bose, Indian scientist, ultra short radio waves, Indian. And Roentgen, discovery of X-ray, Germany. J.J. Thomson, electron, UK. And Curie, discovery of radium polonium, studies on natural radioactivity, Poland. Albert Einstein, explanation of photoelectric effect and theory of relativity. Theory of relativity, there only E equal to mc square. It belongs to Germany. And this is a major contribution for some more scientists, that is Millikan, measurement of electronic charge, USA. Sir C.V. Raman, Indian scientist, inelastic scattering of light by molecules. He only proved that why sea or sky appears blue, that is due to scattering of light by molecules. That is only inelastic scattering of light by molecules. De Broglie, wave nature. Saha, thermal ionization. S. N. Bose, quantum statistics. Pauli, explosion principle, Austria. And Hubble, expanding universe, USA. That is called famous Hubble law. Universe is expanding as Big Bang theory. James Chadwick Newton, UK. Yukawa, theory of nuclear force, Japan. Baba, Homi Baba, cascade process of cosmic radiation, India. And S. Chandrasekhar, his uncle only Sir C.V. Raman, and he is also another Nobel laureate. Chandrasekhar limit, that is structure and evolution of star, belongs to India. Actually, he only proved that which stars and all goes for, that is the birth and death of a star. Like other living beings, stars also born, that is the birth of a star, and going to die as a death of the star, as a white dwarf or supernova explosion or black hole. He estimated one value, that is only Chandrasekhar limit. That is estimated the mass of the sun. That is 1.3 times of mass of the sun, that will be Chandrasekhar limit. And these are the link between technology and physics. Steam engine, law of thermodynamics. Nuclear reactor, controlled nuclear fission. Radio and television, generation, propagation and detection of electromagnetic wave. Computer, logic gates, digital logic gates. Laser, light amplification by stimulated emission of radiation. Production of ultra high magnetic field, superconductivity. What is superconductivity? It is a phenomenon that is a certain material exhibit zero resistivity or infinite conductivity at very low temperature. For this only I said example already as bullet train, Japanese bullet train, fastest train around 601 km per hour. That is recorded as a fastest train. That is based on superconductivity Meissner effect. diamagnetic property. Rocket propulsion, Newton's law of motion. Electric generator, Faraday's laws of electromagnetic induction. Hydroelectric power, conversion of gravitational potential energy into electrical energy. Aeroplane, Bernoulli's principle used in fluid dynamics. Aerodynamics. Particle accelerator, motion of charged particle in electromagnetic field. Sonar. What is sonar? Sound navigation and ranging. It's used in reflection of ultrasonic waves. Optical fiber principle is total internal reflection. Non-reflecting coating, thin film optical interference. Electron microscope, wave nature of electron, that we already discussed. Wave nature of electron, that is called de Broglie wave. Photocell, photoelectric effect. Fusion test reactor, that is magnetic confinement of plasma, because 10 power 7 or 10 power 6 degrees Celsius, there is no container to hold that temperature. So there is a magnetic confinement of plasma that will be used. And giant meter wave of radio telescope, detection of cosmic radio waves. Bose-Einstein condensation, trapping and cooling of atoms by laser beam and magnetic fields. Okay. Let's move to chapter 2, units and measurements. We know physical quantities, that is a length, mass, time, force, speed, pressure, everything is physical quantity, but basically physical quantities are classified into two. One is fundamental quantity, another one derived quantity. Okay. Physical quantity can be classified as two: fundamental quantities and derived quantities. These are the difference between basic, fundamental and derived quantities. Fundamental quantities or units are all those units which are independent of other unit, or quantity means fundamental quantity are those quantity which are independent of other quantity. And example, length, mass, time. Suppose you measure the length, no need to measure, no need to take care about the mass or time. Derived quantities, derived units are those units which are obtained by multiplying or dividing one or more fundamental units, or depends on other fundamental quantity. Fundamental units cannot be further reduced to elementary level. Derived units can be reduced to its elementary level, which are composed of fundamental units. Fundamental units cannot be expressed in terms of derived, but derived units can be expressed in terms of fundamental unit. And there are 7 fundamental units or fundamental quantities as per SI system. And there exists large number of derived quantities or derived units. 7 fundamental quantities or units. Units are meter, kilogram, second, Kelvin, mole, ampere, candela. Quantity means length, mass, time, temperature, amount of substance, current. Candela is luminous intensity. And derived units, derived quantities: force, Newton; energy, joule; power, watt; potential, volt; pressure, Pascal; temperature, Celsius. These are all derived units with derived quantities. There are different systems of units are used, that is length, mass, time. FPS means foot, pound, second. It is a British system of unit. Okay, they measured length in foot, measured mass in pound, measured time in second. CGS, they measured length in centimeter, measured mass in gram, time in second. MKS, meter, kilogram, second, measured length in meter, mass in kilogram, time in second. So there will be a different system of unit like this. So there should be a common system of units must be adopted, that is called SI unit. Okay. SI unit is a remodification of MKS unit. Slight modification of MKS unit is SI unit. What is expand SI? What is SI? System International D units or International System of Unit, that is SI unit. And unit is an internationally accepted standard for measurement of quantities. It was developed and recommended by General Conference on Weights and Measure in 1971 in Paris. SI lists 7 base units. Along with it, there are 2 units, radian or steradian, that is called supplementary units or supplementary quantity. and these are dimensionless. And SI units: length measured in meter, symbol M; mass measured in kilogram, kg; temperature Kelvin, capital K; time in second, small s; amount of substance, mole, MOL; electric current, ampere, A; luminous intensity, candela, CD. These are the 7 basic or fundamental units, basic units or fundamental units as per SI system of units. And each, for example, length, 1 meter means 1 meter is the length of the path travelled by light in vacuum of 1 by 299,792,458 of a second. This is nothing but velocity of light, 2.99 into 10 power 8 of a second. And mass is kilogram, and 1 kilogram is the mass of prototype cylinder of platinum iridium bar, which is in the International Bureau of Weights and Measure in Paris in France. And time is in second. 1 second is 9,192,631,770 periods of radiation correspond to transition between 2 hyperfine levels of ground state of cesium-133 atom. Cesium-133 atom which transits from one energy level to other energy level. That time period will be this much. This is equal to 1 second. And electric current, 1 ampere is the constant current which will maintain between 2 straight parallel conductor of infinite length and negligible cross section held 1 meter apart in vacuum shall produce a force per unit length of 2 into 10 power minus 7 Newton per meter. This is 1 ampere. And Kelvin, 1 Kelvin is a fraction of 1 by 273.16 of triple point of water. What is triple point? Triple point means is a point or constant temperature in which all the 3 states can be existing. At this temperature and pressure, water exists in liquid state as well as solid state as well as steam state, gaseous state. And amount of substance, 1 mole is there are atoms in 0.012 kilogram of pure carbon 12. That only we studied as 1 by 12th of the mass of the carbon atom, 1 AMU, like that we studied. Luminous intensity, candela. 1 candela is the luminous intensity in a given direction of a source that emits monochromatic radiation of frequency 5.4 into 10 power 14 Hertz, and that has radiation intensity of 683 watt per steradian. See, I said triple point of water is the temperature at which saturated vapor, pure and melting ice all are in equilibrium. The triple point of water is 273.16 Kelvin. Okay. And some units retained for general use other than SI. Minute, 60 second; hour, 60 minutes or 3600 second; day, 24 hour or 86,400 second; year, 365.25 days or 3.156 into 10 power 7 second; degree, 1 degree equal to pi by 180 radian. That is the relationship between radian and degree. Pi radian equal to 180 degree. Liter is equal to 1 decimeter cube equal to 10 power minus 3 meter cube. Ton, 1 ton is 1000 kilogram. Carat, 200 milligram. Where we are measuring carat? Is it vegetable? Yes, gold. Gold diamond are measured in carat. Bar is 0.1 MPa. What is MPa? M megapascal. It is a unit of pressure, and that is approximately 10 power 5 pascal. Curie is 3.7 into 10 power 10 per second. Disintegration per second. Roentgen, 2.58 10 power minus 1 coulomb per kilogram. Quintal, 100 kilogram. Air, 1 DAM square equal 10 power 2, 100 meter square. Hectare, 1 HM square, that is equal 10 power 4 meter square. Standard atmospheric pressure, that is 1 atmospheric pressure is the pressure exerted by the atmospheric gases on our body throughout the earth. Value is 1.013 into 10 power 5 pascal. range of length, size of object or distance, size of proton 10 power minus 15 meter, size of atomic nucleus 10 power minus 14 meter, size of hydrogen atom in Armstrong 10 power minus 10 meter, length of typical virus in micrometer 10 power minus 6 meter. Actually biology range is up to 10 power minus 6 only. In biology we are using micrometer range only. Wavelength of light 10 power minus 7 meter or even in nanometer or Armstrong. Armstrong will be mostly used value for wavelength. Size of RBC 10 power minus 5 meter. Thickness of paper 10 power minus 4 meter. Height of Mount Everest, that is 10 power 4 meter or 10 kilometer. Radius of Earth 10 power 7 meter approximately 6.02 into 6.6 into 10 power 6 meter is a correct value. And distance of moon from the earth 10 power 8 meter. Distance of sun from the earth 10 power 11 meter, that is astronomical unit. Distance of Pluto from the sun 10 power 13. Size of our galaxy 10 power 21. What is the name of our galaxy? Milky Way galaxy. Milky Way galaxy. Indian name Akash Ganga. Distance to Andromeda galaxy. Andromeda is the next galaxy, near neighbor galaxy. That is 10 power 22 meter. Distance to the boundary of observable universe approximately 10 power 26 meter. Large distance. Measuring large distance. We can measure large distance by different method. One such method is parallax method. Parallax is a displacement or difference in the apparent position of an object viewed along two different lines of sight and is measured by the angle or semi-angle of inclination between these two lines. Distance between the two viewpoints is called basis. This only. That is a different viewpoint. There is one object. Suppose if it is viewed at a point A, background will be like this. Viewed at point B, it will be here. Then based on that, it will be measured as this formula. That is R equal to x by theta. This is the theta and x is the distance between the two vision, and R is the distance between the distant object and our point. And R equal to x by theta. It's taken from the length of an arc formula only. That is a parallactic angle formula. From that only parsec will be obtained. 1 parsec equal to 3.26 light year. That will be taken from this as a parallactic angle. And measuring very small distances. To measure distances as low as size of molecule, electron microscopes are used. These contain electrons beam controlled by electric and magnetic field. Electron microscope have a resolution of 0.6 Armstrong. Armstrong means 10 power minus 10 meter. That is, any object or any point in between that distance is 0.6 into 10 power minus 10 meter. That can be resolved using electron microscope. 1 Armstrong 10 power minus 10 meter. Electron microscope are able to resolve atoms and molecules while using tunneling microscopy. I said no. Last class I said I think electron microscope, scanning electron microscope, tunneling electron microscope, like the different types are there. That one. It is possible to estimate size of the molecule. Size of the molecule can be estimated using microscope, electron microscope. Advanced version is tunneling microscope. Estimating size of molecule of oleic acid. Oleic acid is a soapy liquid with large molecule size of the order of 10 power minus 9 meter. That can be obtained from another method. Measurement of mass. Mass is usually measured in terms of kilogram and molecules as unified atomic mass unit U or AMU. And it's nothing but 1 by 12th of the mass of the carbon atom. It is the 1 by 12th of the mass of the carbon atom. Here also I asked one question. Okay. Including mass of electron, and is 1.6. Actually mass of the proton, its value is 1.66 into 10 power minus 27 kilogram. Apart from using balances for normal weight, mass of planets is measured using gravitational method, and mass of atomic particles are measured using mass spectrograph. Okay, mass of the earth is approximately 10 power 24 kilogram. Mass of the sun 10 power 31 kilogram. Okay, these and all we can measure using gravitational method. And another one, small particles, atomic particle can be measured using mass spectrograph. That only you may study in your +2 nuclear physics as Bainbridge mass spectrograph. Range and order of masses, like length, different range of mass also. The electron mass is 10 power minus 30 kilogram, proton 10 power minus 27 kilogram, uranium atom 10 power minus 25 kilogram, RBC 10 power minus 13 kilogram, dust particle 10 power minus 9 kilogram as nano, raindrop 10 power minus 6 kilogram, mosquito 10 power minus 5 kilogram, grape 10 power minus 3 kilogram, human 10 power 2 approximately, that is around 100 or less than 100. Okay, 50 to 100 will be average mass of the human being. Automobile 10 power 3, around 1000. Boeing 747 aircraft 10 power 8 kilogram. Moon 10 power 23. Earth 10 power 25. That is 6 into 10 power 24 is the correct value. Sun 10 power 30. 1.989 10 power 31 kilogram. Milky Way galaxy 10 power 41. Observable universe 10 power 55 kilogram. Okay. And fundamental quantities over. Now derived quantities. Some of the derived quantities. These two, plane angle and solid angle, not derived, supplementary quantity. Its unit radian, steradian. Area, length into breadth, meter square. Volume, area into height or length into breadth into height, meter cube. Velocity, distance by time or displacement by time, meter per second. Acceleration, rate of change of velocity. Velocity by time, meter by second square. Angular velocity, angular displacement by time, radian per second. Angular acceleration, angular velocity by time, radian per second square. Density, mass by volume, kilogram per meter cube. Linear momentum, mass into velocity, kilogram meter per second. Moment of inertia, mass into distance square, kg m square. Force, mass into acceleration as SI unit Newton. Pressure, force by area, that is Newton per meter square or Pascal. Energy, force into distance, joules. Power, work into time, watt. Impulse, force into time, Newton into second. Surface tension, force per unit length, Newton per meter. Moment of force, force into distance, force into perpendicular distance. That is nothing but moment of force, moment of couple or torque. That is Newton into meter. Electric charge, current into time, ampere into second or coulomb. Current density, current by area, ampere per meter square. Magnetic induction, force by current into length, that is Tesla. Force constant, force by displacement, Newton per meter. Planck's constant, joules into second. Specific heat, joule per kilogram per Kelvin. Boltzmann constant, joule per Kelvin. Dimensional formula. Like unit, SI unit, dimensional formula also another important measurement. Dimension of physical quantities. All the derived physical quantities can be expressed in terms of some combination of 7 fundamental or basic quantities. These base quantities are known as dimensions of the physical world and are denoted with square bracket. The 3 dimensions in mechanics are L for length, M for mass, capital M, change it, capital M for mass, and T for time. Length, mass, time. And some other physical quantity dimension formula with SI unit also. Area, length into breadth, m0 L square T power 0, SI unit meter square. Volume, length into breadth into height, just L cube. Density, mass by volume, m L power minus 3. Speed, distance by time, L T power minus 1. Velocity also same, but displacement by time, L T power minus 1, that is meter per second. Acceleration, change in velocity by time, meter per second square is dimension formula L T power minus 2. Acceleration due to gravity, same as acceleration, L T power minus 2. Specific gravity, no dimension, no units. Because density of body compared with the density of water, that is a specific gravity or relative density. Linear momentum, mass into velocity, kilogram into meter per second, and m L T power minus 1. Force, mass into acceleration, ml t power minus 2 Newton. Work, force into distance, ml square t power minus 2 Joule. Energy, ml square t power minus 2 Joule. Impulse, force into time, ml t power minus 1 n into s. Pressure, force by area, ml power minus 1 t power minus 2. Power, work by time, ml square t power minus 3, unit is watt. Universal gravitational constant. This also we can say F equal to G m1 m2 by r square. We can write. There is no blank. Wait. Where is the cursor? We know the formula F equal to G into m1 m2 by r square. So from this G equal to means Fr square by m1 into m2. G equal to F r square by m1 into m2 as m square. Okay. And its SI unit Newton meter square per kilogram square. Dimension formula m power minus 1 L power 3 t power minus 2. Moment of inertia, that is I equal to mr square formula m L square kg m square SI unit. Moment of force or moment of couple or torque tau. Force into distance m L square t power minus 2. Surface tension, force by length, L power 0 t power minus 2. Surface energy, energy per unit area, L power 0 t power minus 2. Force constant, force per distance, Newton per meter. Coefficient of viscosity, this also we can derive, that is L power minus 1 t power minus 1. That is Ns m power minus 2. Thrust, that is force. Thrust is nothing but force. L t power minus 2 Newton. Tension also force, same unit. Stress, force by area, same as pressure. L power minus 1 t power minus 2 unit Newton per meter square. Strain, change in dimension to the original dimension. That is, there may be a change in length by original length or change in volume by original volume, same unit, so no dimension, no unit. Modulus of elasticity, stress by strain, same as stress. What stress dimension formula, what stress unit, same as that. That is modulus of elasticity. Radius of gyration, that is L power 1 only, that is m. Angle theta or angular displacement is nothing, is at no dimension but unit radian. Okay. And trigonometric ratio, sin theta, cos theta, tan theta, this and all. That is no dimension but and also no unit. Okay. Specific gravity or relative density. Specific gravity or relative density. And in this many times question will be asked, that is following or the dimensionless quantity, unitless quantity, like that. Okay, there we have to watch from these questions, these topics. And one more thing, that is okay, strain is a no unit, no dimension. Yes, trigonometry is another one. Angular velocity, angle by time, that is t power minus 1 unit radian per second. Angular acceleration, angular velocity by time, that is per second square or t power minus 2. Angular momentum, ml square t power minus 1. Torque, moment of inertia into angular acceleration, ml square t power minus 2. Velocity gradient, velocity by distance. Rate flow, volume by time, L cube by t, t power minus 1. Wavelength, length of the wave, L power 1 only, unit meter. Frequency, number of vibration per second or number of oscillation per second or reciprocal of time period as t power minus 1. SI unit, hertz. Angular frequency omega, 2 pi into frequency or 2 pi by t, that is t power minus 1. Unit of angular frequency is radian per second. This also radian per second. Planck's constant, energy by frequency, ml square t power minus 1 unit joules into second. Okay, uses of dimensional formula. To check the correctness of the equation. Suppose V, that is the equation of motion is there, V equal to u plus at. Suddenly you forgot. V equal to U plus AT or U plus AT square. If you know the dimension formula idea, you can check it. Same way, second equation of motion, S equal to UT plus half AT square. Where is the cursor? S equal to UT plus half AT square. I am having doubt whether AT square or AT cube. We can check it. And to convert the value of one physical quantity from one system to other system of unit. That is, you are having doubt 1 meter equal to how many centimeter. You can check it. Okay. Same way, 1 joule equal to how many EV. You can check it. And to derive the relation between various physical quantity, one physical quantity to other. That is, you are having doubt whether V equal to displacement by time or V equal to displacement into time or V equal to time by displacement. You can check it. Okay. To derive the relationship between one physical quantity and other. To find the dimensions of dimension constant. Many places we use this is directly proportional to, for example, F is proportional to M1 into M2 by R square. What law this is? Newton's law of gravitation. Coulomb's law is Q1 into Q2 by R square. Okay, Coulomb's law in electrostatics, and Coulomb's law in magnetostatics, F is proportional to, that also M1 into M2 by R square, that is pole strength, and here M1 into M2 here mass, force due to gravitation, and F is proportional to M1 M2 by R square, and here F equal to K into M1 into M2 into R square, that is equal to G into M1 into M2 by R square. Then you can find the dimension of dimension constant using this. Limitation. It has some limits. This method gives no information about the dimensionless constant in the formula like 1, 2 up to pi, etc. This method cannot decide whether the given quantity is a vector or a scalar. That cannot be found using dimension method. This method is not suitable to derive relation involving trigonometric, exponential or logarithmic function. Suppose there is one formula in optical fiber will come, numerical aperture equal to sine of the acceptance angle as theta A. So these things we can't check it. Whether numerical aperture equal to sine of theta A or sine inverse of theta A, that we can't check using this. And same way, mu equal to sin I by sin R. So wherever sin, tan, that and all coming, you can't check it. It's one of the drawbacks or limitations. It cannot be applied to an equation involving more than 3 physical quantity. That is, for example, sum of the physical quantity, that is F depends upon Q1, Q2, R square and R square. So 3R, what's the relationship between Q1, Q2, R or MR, like that? Only 3 quantities, Q1, Q2 will be one quantity, and only Q, R and some more, 3 quantities only we can use. More than 3 quantity we can't. Okay. And it can only check on whether a physical relation is dimensionally correct, but not the correctness of the relation. Dimensional only correct that we can check. For example, using dimension analysis, S equal to UT plus 1 by 3 AT square or 1 by 2 AT square, that you can't check. UT plus AT square or AT power 3 or just AT, that only you can check. Whether 1 by 3 or 1 by 2 or 1 by 10, that we can't check. Okay, that is the 5th one. Accuracy and precision. Any uncertainty resulting from measurement by measuring instrument is called error. They can be systematic or random. Accuracy of a measurement is how close the measured value is to the true value. Precision is the resolution or closeness of a series of measurements of a same quantity under similar condition. If the true value of certain length is 3.678 centimeter and 2 instruments with different resolution, up to 1 less precise, up to 2 is more precise, decimal places are used. If first measures the length as 3.5 and the second measured as 3.38, then the first has more accuracy but less precision. That is, precision means number of digits. For example, I am measuring my height. Example, I am saying my height is 173 centimeter. Okay. And suppose if we use accurate measurement, some other measurement as 172.89, then which is more accuracy means this one is more accuracy. Okay, like that. Then the first has more accuracy but less precision, while the second has less accuracy, more precision. Accuracy and precision are different, opposite. Next, significant figures. The digits of number that are meaningful in terms of accuracy or precision, that is called significant figures. That is the number of meaningful digits in a given number. That is called significant figures. To represent the result to a correct number of significant figures, we round off as per the rules. There are 3 rules on determining how many significant figures are in a number. Non-zero digits are always significant. 5, 52, 65, 628, 525.25, 525.25 means all the 5 are significant, non-zeros. And any zeros between 2 significant digits are significant. That is 506 means then 3 significant figures. A final 0 or trailing 0 in the decimal point only are significant. For example, 560, like that means then 3 significant figures. This 0 will be taken, considered. Rule 1. Non-zero digits are always significant. Number like 26.38, 4 significant figure. This one, 3 significant figure. Any zeros between 2 significant figures, that is 406, 3 significant figures. A final 0 or trailing 0 in the decimal portion only are significant, and trailing 0 in a whole number are not significant. That is before that. 0.052 means this 0.0 is not significant. 2 is only significant digits. Rounding off. If the digit to be dropped is less than 5, then the preceding digit is less unchanged. Example, 8.22 is rounded off to 8.2 because it's less than 5. And if it is more than 5, then the preceding digit is raised by 1, that is 6.87 means then you want to round off to 2 digit means 6.9. This 7 is greater than 5, so round off. If the digit to be dropped is 5 followed by digit other than 0, then the preceding digit is raised by 1, that is 7.851 is rounded off to 7.9. That is if it is more than 5, we can round off. If it is in 5, and you have to check after 5 followed by what number. Suppose if it is not 0, then you can round it off as 7.9, increase by 1 number. Suppose here instead of 1, 0 is there, then there will be no change. Okay, see. The digit to be dropped is 5 or 5 followed by 0, that is 5.250. Here 0 is there. So 0 is there means there will be no change, just 5.2. Okay, understand? No. See, in previous, after 5 followed by non-zero, except 0, any other number is there, then you can round off this 7.85 as 7.9. Instead of 1, 0 is there, then you should not increase as 7.9, just leave as 7.8. Okay. Here is given some other number. And if the digit to be dropped is 5 or 5 followed by 0, then the preceding digit is raised by 1 if it is odd. That is 3.750 is rounded off to 3.8 if the number is odd number. And accuracy is the extent to which a reported measurement approaches the true value of the quantity measured. Uncertainty or error, other name is error, is a measurement is called error, random error, systematic error, gross error, or the 3 possible errors. Systematic error. These are reproducible inaccuracies that are consistently in the same direction. These occur often due to a problem that persists throughout the experiment. Systematic errors can be classified as instrumental error, that is, when an instrument is not calibrated properly at the time of manufacture, instrumental error may arise. Calibration is a very, very important one. In colleges and all, in lab, that is during inspection, Anna inspection like that will come and visit. And they will come first straight away to lab only. In lab, they will check only this calibration certificate. For what experimental law we will do calibration certificate means screw gauge, vernier caliper. These two only we will calibrate. What they will do is from the calibration, that is a different scientific, that is the companies are there, and we will approach them, or they will come and they will take one screw gauge and one vernier caliper, and they will service it. Okay, and it has no zero error. That is it has completely error, no error. Okay, no error will be there, and that is a calibrated one. And they will give certificate also for that. That is called calibration certificate. It's valid for only 1 year, and next year we have to renew that another screw gauge we have to give, and they will give another certificate. And inspection they will see calibration certificate for that. So just to reduce the error or rectify the error, we will use calibration. If a measurement is made with a meter scale whose end is worn out, the result obtained will be error. In meter scale, if it is not sharp like this, if it is worn out like this, then some error will occur. And these errors can be corrected by choosing the instrument carefully. Instead of old scale, new scale you can take, best scale you can take. Imperfections in experimental technique or procedure. These errors arise due to the limitation in the experimental arrangement. As an example, while performing experiments with a calorimeter, if there is no proper insulation and there will be a radiation loss, this results in error, and to overcome this, necessary correction or condition has to be used. Personal errors. These errors are due to individual performing the experiment, may be due to incorrect initial setting up of the experiment or carelessness of the individual making the observation due to improper precaution. Errors due to external cause. To change in the external condition during experiment can cause error in measurement. For example, changes in temperature, humidity or pressure during measurement may affect the result of the measurement. Least count error. Least count is the smallest value that can be measured by the measuring instrument, and error due to this measurement is least count error. The instrument's resolution hence is the cause of this error. Least count error can be reduced by using high precision instrument for the measurement. For example, instead of vernier caliper, you can use screw gauge. Screw gauge is least count of screw gauge is 0.01 millimeter. And least count of vernier caliper is 0.01 centimeter. What? Glass? Glass slab. Glass slab is material only. Using glass slab experiment. Okay. Then that is traveling microscope. Name of that is vernier microscope or traveling microscope. That least count is 0.001 centimeter. Okay. This is a traveling microscope as a vertical displacement, horizontal displacement. What is the main use in your level means that in your level I am thinking that is repeat experiment name. Refractive index of which one?
Of a glass lab using
lycopodium powder. Okay, okay. Okay. That source, what source of light you used? Light?
No, sir, no light.
No light. Normal visible light. Okay. And in your level I am saying means, okay, you did that one also. Capillary tube. That small hole will be there. That diameter of the capillary tube can be determined using vernier microscope. vertical diameter, horizontal diameter. From that we can do it. Okay. And random errors may arise due to random and unpredictable variation in experimental conditions like pressure, temperature, voltage supply, etc. And it may be due to personal errors by the observer who performs the experiment. And these are sometimes called chance error. When different readings are obtained by a person, every time he repeats the experiment, personal errors occurs. For example, consider the case of the thickness of a wire measured using a screw gauge. The readings taken may be different for different trials. In this case, a large number of measurements are made and then the arithmetic mean is taken. That's why in screw gauge or vernier caliper, staffs we are asked to take at least minimum 5 readings. 5 reading or 7 readings. In there 1 or 2 reading only you may commit mistake and other 3 or 4 will be correct value. So by adding the average of all these, add all the 5 divided by 5, then error will be rectified. That is a random error. Gross error is due to sheer carelessness of an observer is called gross error. For example, reading an instrument without setting it properly. That is, even for spectrometer, initial adjustment of the spectrometer should be made. That is, the telescope should be adjusted for the distant object and the collimator should be adjusted. It should, and yes, that width of the slit should be adjusted as a thin and eyepiece should be adjusted, and collimator, that prism table should be adjusted as a horizontal, like that, some initial adjustment. Taking observation in a wrong manner without bothering about the source of error and the precaution. Recording wrong observation. Using wrong values of observation in calculation. These errors can be minimized only when the observer is careful and alert. Absolute error, difference between the true value and the measured value of a quantity. True value, actual value, that is G equal to 9.8 meter per second square. That is the, what is that? What is G? G is the acceleration due to gravity on earth. And you are measuring using simple pendulum, G equal to, suppose you are getting 9.782 meter per second square. Then absolute error is different between these two, 9.8 minus 9.782. 9.782 is the measured value. Okay. And if A1, A2, A3, that is the n number of times we are taking, and A in the experiment performed n times, then the arithmetic mean of this value is the true value. That is A1 plus A2 plus A3 plus up to AN divided by n. See, AM is given divided by n, or AM equal to 1 by n summation I equal to 1 to n AI. And delta A1 equal to AM minus 1, A1, AM minus A2, like that. And mean absolute error, delta AN equal to delta A1 plus delta A2 plus delta A3 up to delta AN by n. Percentage error equal to measured value minus actual value by actual value into 100. That is the percentage error. Measuring instrument. Different measuring instrument in our level: vernier caliper, screw gauge and spectrometer. Okay. This is a vernier caliper, and how to determine least count? N division of vernier scale division equal to n minus 1 division of main scale division. Then 1 VSD means n will goes down as n minus 1 by n. N minus 1 by n. And least count equal to 1 MSD minus 1 VSD. So in questions and all, MSD is given and coincidence VSD is given, and you can find least count. Least count of vernier caliper is standard vernier caliper 0.01 centimeter. Least count 0.01 centimeter. This is a pictorial of vernier caliper. And this down scale is in centimeter, this will be in inches. This is a problem, no need. Screw gauge. Least count equal to pitch by number of divisions on head scale. This is a screw gauge. Least count is 0.01 millimeter. Here this one is pitch scale, and 20, 25 like that, that is a head scale. Spectrometer. N division of vernier scale division equal to n minus 1 division of MSD. Then n minus 1 by n of MSD. Least count of spectrometer is 1 minute. 1 by 60 degree equal to 1 minute. That is, in a vernier scale, value will be in minute. Okay. Right. So, chapter 3 will complete that. Motion in a straight line. Motion in straight line or motion in one dimension. Mechanics. Mechanics is a branch of physics which deals with the study of motion of physical bodies. Mechanics can be broadly classified into following branches: statics, kinematics, dynamics. Statics is a branch of mechanics which deals with the study of physical bodies at rest. Study of physical body at rest, that is statics. Kinematics. It is a branch of mechanics which deals with the study of motion of physical bodies without taking into account the factor which causes motion. That is, a cause cannot be observed. Dynamics. It is a branch of mechanics which deals with the study of motion of physical bodies taking into account the factors which causes motion. That is, by the application of force only the object is in motion. By the application of force only pressure will be happening. Like the discussion is dynamics. Next. Rest and motion. Rest. An object is said to be at rest if it does not change its position with respect to the surrounding. Whiteboard in the classroom is at rest with respect to the classroom. Motion. An object is said to be in motion if it changes its position with respect to the surrounding. When we walk, run or ride a bike, we are in motion with respect to ground. Okay. Rest and motion are relative and it depends upon the observer, where the observer is. Object in one situation may be at rest, whereas the same object in another situation may be in motion. Driver of a moving car is in motion with respect to an observer standing on the ground. In the ground, the man is at rest. So, the driver of a moving car is in motion. And in the same driver is at rest with respect to the man in the passenger seat. Backside or next, suppose other person is sitting. For him, driver is in rest only. Position. Position of an object is always defined with respect to some reference point which we generally refer to as origin. That only xy is at origin or frame of reference. To define the change in position, we have two physical quantities: distance and displacement. It is the actual path traversed by the body during the course of motion, that is distance. SI unit meter. Dimension m power 0, L power 1, T power 0, just L. L is a dimension, formula of distance. Displacement is the difference between the final and initial position of the object during the course of motion. SI unit same as distance, meter. Dimension formula L power 1. Difference between distance and displacement. It is the actual path traversed by the object during the course of motion. Displacement, change of position. Final position minus initial position. x2 minus x1. Distance is a scalar quantity. Displacement, vector quantity. What are scalar quantity and vector quantity? What are scalar quantity? A quantity which has only magnitude, no direction, are called scalar quantity. What are vector quantity? A quantity which has both magnitude and direction, are called vector quantity. Distance traveled by an object during the course of motion is never negative or 0 and is always positive. Distance never be negative value. There will be always positive value, forward direction only. Or 0 also not possible while it is in motion. And displacement of an object may be positive, negative or even 0. So, for displacement, we are moving from one point to other point. Suppose object is at a point A, from moving to here B, then again come back to same position, then displacement will be 0. Final position minus initial position 0. And suppose you are going some more backward direction as C, then negative displacement. Okay, so displacement may be positive, negative or even 0. Distance travelled is either equal or greater than the displacement and is never less than magnitude of displacement. Magnitude of displacement is less than or equal to the distance travelled during the course of motion. Distance is greater than or equal to displacement. Distance depends upon the path travelled. Magnitude of displacement is independent of path travelled by an object during the course of motion. Scalar quantity which has only magnitude, no direction. Example, length, mass, time, distance, speed, work, temperature, energy, etc. Vector quantity which has both magnitude as well as direction. Example, displacement, velocity, acceleration, force, momentum, torque, pressure, etc. Average speed is defined as the total path length travelled divided by total time taken during which the motion has taken place. SI unit, meter per second. Dimension formula LT power minus 1. Average velocity, change in position or displacement divided by time interval in which displacement occur. Is SI unit, meter per second. Normal general unit, kilometer per hour also will be used in daily application. Dimension formula same as velocity or speed as LT power minus 1. Instantaneous velocity, it is a velocity at a given instant of time and it is defined as the limit of the average velocity as the time interval delta t becomes infinitesimally small. Instantaneous velocity delta x by delta t or dx by dt. SI unit is meter per second. Dimension same as normal average velocity LT power minus 1. Instantaneous speed or speed is a magnitude of velocity. Unit meter per second. Dimension LT power minus 1. Acceleration, average acceleration over a time interval is defined as the change of velocity divided by time interval as A equal to delta V by delta T or V2 minus V1 by T2 minus T1. V1, V2 or velocities at T1 and T2 time and it is the average change of velocity per unit time, SI unit meter per second square. Instantaneous acceleration same way as instantaneous velocity, that is the acceleration takes place at a given instant of time. Dimension formula LT power minus 2, SI unit meter per second square. Meter per second square. Acceleration A delta V by delta T or dV by dt, SI unit meter per second square. Dimension formula LT power minus 2. When the acceleration is uniform, obviously instantaneous acceleration equals with average acceleration over that time period. Then this is the graph for conversion of distance time to velocity time and acceleration time graph. Okay, that is a displacement time graph. Usually time will be taken along x-axis and distance, velocity or acceleration will be taken along y-axis. And this is displacement time graph. Nature of slope is positive. Magnitude of slope constant. And when you convert this displacement time graph to velocity time graph, here as velocity is constant, here it will be come as a straight line parallel to x-axis. Now, nature of slope is 0 and magnitude of slope is constant. Acceleration time graph. Here velocity is constant, acceleration will be in 0. Okay. So, this will be a conversion of displacement time graph to velocity time graph to acceleration time graph. Question will be also in this way. That is, there will be one velocity time graph will be given and convert this into acceleration time graph as different option as a image. Same way, this is another graph having negative slope but magnitude constant. Then nature of slope is 0 and magnitude of slope is constant. Its acceleration will be same as like this, 0 point. Because velocity itself constant, acceleration will be 0. And equations of motion. Equation of motion for uniformly accelerated motion along a straight line. First equation of motion, V equal to U plus AT. Second equation of motion, S equal to UT plus half AT square. Third equation of motion, V square equal to U square plus 2AS. Fourth equation of motion, Sn equal to U plus A by 2 into 2n minus 1. And I think in CBSE, fourth equation of motion is not there. You didn't study, because I came to know that one student said that only 3 equation of motion only, sir. Okay. Then, so what is U? U is the initial velocity, V is the final velocity, A is the uniform acceleration, T time, S displacement, Sn displacement in nth second. And these equations are not valid if the acceleration is not uniform. This is valid only for uniform acceleration. These 4 equation of motion is derived only for uniform acceleration. Okay. Thank you. Right. So 3 chapters we have completed, and in next session we will start